Hi, Bill Barber from Poliigon here. In this video we're going to take a look at how to properly make use of a displacement texture in 3ds Max with Redshift. Before we get started, let's take a look at the material we'll be using. It's ground asphalt broken 001 and is easily one of my favourite ground textures here at Poliigon. It's brilliant for demonstrating this displacement, which is why I picked it. I've already got the 4K version saved to my hard drive and I'll include a link below the video. As a note, I would recommend getting the 4K version if you're going to be following along, because with displacement you really do want as much detail from the texture as possible. So let's take a look at what it is we're going to be doing. You've probably heard of a bump map before, which is used to artificially give the impression of height in a material. Well, a displacement map is different. It is used to literally deform the object based on the values of the texture, with the black areas being the deep crevices and the white areas being the peaks. It results in a far more realistic material. Okay, so let's look at how we replicate that effect in Redshift. We've got a simple scene here, just a plane and a camera and a HDR setup, and that is literally it. And to start off with, we'll load up the material converter, which I've covered in a previous video. I'll link it below this one. But let's use it to bring in our material, ground asphalt broken. There we go. Now you notice mine's actually got a green tick there. That's just because I've imported this material previously. Let's head over to the material editor, and then under the temporary library we've got our what's that note doing there? We've got our imported material. So I'll drag that into the material editor view here. I'm just going to shrink this window down a little, and then we click on the floor plane itself and assign material to selection. Good. Now, if I were to do a rendering now, in fact I would do a rendering now, let's see what we actually get by default. So yeah, not looking particularly great. It's quite clearly a nice PBR material. I can see the different levels of reflectivity and the normal map and everything else doing its job, but it's very clearly a basic material mapped to a flat plane, which isn't really the effect we're going for. So, in fact, I'll load up the material editor again. Now, you might think that the place we need to start adjusting is here, this displacement node, because there's a scale input there and some various other settings, and that's clearly where the displacement map's being plugged into. But no matter how much you play around with these numbers, you're not really going to see much of an effect. Reason being is we need to tessellate this geometry. We need to take this, because at the moment it's what, about 10 by 10 quads that make up this plane. We need to give it way more geometry for the displacement to be able to properly displace this plane. So to do that, head over to the modifier panel. Okay, so the one we need is a Redshift mesh parameter. Yes. Now what this will do is give us some additional controls to play with. We've got a whole section on tessellation here, and then a separate part on displacement here. So let's do a render now and see if just adding in that modifier has done much. I'll give you a clue, it probably hasn't. So yeah, if you look really closely, you could just about start to see a little bit of change there. But obviously not enough. But now we've got the modifier in there, it's literally just a matter of tweaking the settings. Now this uses adaptive displacement, which basically means that the geometry that's closer to the camera will get subdivided more than the geometry that's further away, which is good. So we're not going to really think in terms of subdivisions. Instead we're going to think in terms of edge length, yeah, how long in pixels an edge needs to be before it warrants getting subdivided. Now by default it's on 4, we're going to lower that down to 2. I'll leave the max subdivisions as is for now, and we also need to adjust these scale factors, because you've got max displacement, which is currently at like 0.001 meters. We don't really want that, let's set that to 1 meter. And then you've got the displacement scale, and that's kind of a multiply value for the displacement texture that's already been imported by our material converter. So if I up that to something like 7, and then give it a render again. It might take a little bit longer to process because it'll be doing more tessellation now. There we go. Now that's a bit more like it. In this case, probably a little too high. We're probably going to want to lower the scale to about 4, maybe 4.5, something like that. And I think we've actually got enough subdivision with that value of 2. Do be careful when you start playing with that. If you set it too low, you will start gobbling up your RAM quite quickly. But I'm going to lower that just a little bit more to say 1.7, and we'll give that a final render, and I think that will about do us. Okay, so now we have our final render, and yeah, it's looking pretty good. I've got the camera a bit zoomed out here, so we're seeing the tiling of the texture, but certainly if it was a little closer, it would be pretty good. Or if you were being this zoomed out, just modify the plane a little bit so it's not just a completely flat plane. Give the ground a bit of shape to it. But yeah, looking good. So in summary, we've imported a material from Poliigon.com, set up the displacement via the Redshift mesh parameters modifier, played around with the settings until we get the level of displacement and tessellation that we wanted, and then rendered it out with Redshift.